So last section of chapter 4 today. We've been talking about polynomials all throughout this chapter, how to solve them, different types of polynomials. Here, we're still talking about polynomials, but what we're going to be looking at is how to solve a polynomial inequality. So now instead of having an equal sign in there, we're going to have one of our less than, greater than, less than or equal to, greater than or equal to symbols. And we're going to talk about what that solution would look like within that. Make a mess?
No, the leg just came off.
The leg came off of the chair?
Yeah, I just pulled it came out.
Nobody's even sitting in it?
Nope.
Oh, of the table, not the chair, the table. Interesting. Wonder what you're doing back there. Is it wobbly?
Apparently.
All right, so on this very first one, we're going to solve three things. We want to know, when is this polynomial, f of x, equal to 0? That's what we've been doing all throughout this chapter. When is it less than or equal to 0? When is it greater than or equal to 0? Okay, and there's a couple of different things in here that you could do, right? But in this case here, when I say when is it equal to 0, it's simply just taking this polynomial and setting it equal to 0, right? We're trying to figure out what values of x make this polynomial equal to 0. So we're just solving it. And in most of these cases, a lot of these cases, we're going to be able to factor it, okay? Or we could put it in the calculator too, because it's a quadratic. But factoring this one would be pretty easy. Do product and sum here. What multiplies to get negative 15 and adds to get 2. So that would be a positive 5 and a negative 3. But remember that those are the factors. Those are not the zeros. So then I have to set both of those factors equal to 0. And that would give me x equals negative 5, x equals 3. So those are the two places, two x values that make this equation equal to 0. When we look at the inequality portion of it, we're going to put those two numbers on a number line. And there's a lot of different ways that you can do this. You could test it. So I could pick out numbers that are to the left of negative 5, between negative 5 and 3, which I'm going to use 0 because 0 is really easy. And then I could pick a number to the right of 3. And I could plug those numbers in, and I could see, is it less than or equal to 0? Okay? Or is it greater than or equal to 0? So when I plug in negative 6 squared is 36. 2 times negative 6 is negative 12. So 36 minus 12 would be 24. 24 minus 15 would be 9. Okay? And that is positive. And so what I'm going to do here is I'm going to say when I plug in negative 6, I get a positive answer. When I plug in 0, 0 squared plus 2 times 0 is still 0, minus 15 would be a negative 15. Negative 15 is less than or equal to 0. It is negative. So we get a negative answer. So any number that I plug in between negative 5 and positive 3 would be negative, okay? And then if I pick a number to the right of 3, any number you want, we chose 4. 4 squared would be 16. 2 times 4 is 8. 16 plus 8 is 24. 24 minus 15 is 9 again. 9 is greater than or equal to 0, so that is positive. So it's positive to the left of negative 5, it's negative in between negative 5 and 3, and it's positive to the right of 3. So as we write our solution here, then when is this function less than or equal to 0? Well, it's negative between negative 5 and 3, but because it says equal to, then we're going to include negative 5 and 3. And so what we're going to use here is we're going to use brackets. From negative 5 to positive 3 is where this graph would be negative. Okay, I'm going to show you another way you can do it here, but I'm just trying to get you to understand you can just plug numbers in. Okay, when is this graph positive? Well, we said it's positive to the left of negative 5 and to the right of 3, right? And so those are the two places that it's positive. So this is the one that has a little bit different notation. How far to the left of negative 5? Well, forever. Any number to the left of negative 5 is going to work. So what we call there is we call it negative infinity, all the way to the left. Negative infinity all the way to negative 5, and we're going to include negative 5. And then we have a little break in there. And then we're going to start over again at 3. And we're going to say, oops, I should be a bracket over here at 3. So this would be 3 to infinity. Okay, I think an easier way of doing this is graphing it. Okay, and I'm going to show you a real easy way to tell this graphically. Plugging a number is okay, but it takes a little bit of work, right? You got to plug it in, you got to evaluate it, you got to see what kind of value you get. If you make a little bit of a mistake with positives or negatives, that could throw your number off. If we were to graph this, and you could put this into your calculator if you want to. Those are the two places this graph is crossing the x-axis. So you have a parabola that kind of looks like that, right? That's just a real basic sketch of this graph. We already said those are the two places that it's going to cross the x-axis at. Okay? And if we wanted to know when is it less than or equal to 0, we're really saying when is it equal to 0 or negative. Okay? Both of these places is when it's equal to 0. At negative 5 and positive 3 is when it's equal to 0. So we're including those two in our answer. And then at negative 5, as this graph continues on, negative 5 is where it drops below, and it stays below the x-axis until it gets over here to 3, right? So we're saying from negative 5 to positive 3, this graph is going to be less than or equal to 0. If we wanted to know when is this function greater than or equal to 0, we're really wanting to say when is it positive. When is it above the x-axis, okay? It's above the x-axis here, it's above the x-axis here. That's when we have positive y values. So everything to the left of negative 5, everything to the right of 3, okay? So you can do it by plugging it in, but this would be kind of a quick and easy way visually to kind of determine where it would be, okay? Questions on that? Now, we're not going to do all three of these on every single question. Okay, here we're just kind of talking about how we would get all three of those, but sometimes it'll just be less than or equal to 0. Sometimes it'll be greater than or equal to 0. It could be any of those. So if I give you one like this, x squared plus x minus 2 is greater than 0. We got to pay attention to our inequality. Make sure it's set equal to 0 or greater than 0 in this case. So the same as what we've been doing throughout the entire chapter. Always make sure you get the whole polynomial on one side. But on this one, we just want to know when is this polynomial greater than 0. Now, I would tell you that you could factor this and you could find out the x-intercepts pretty easily. But I'm also telling you that you can use your calculator here, right? And so do you have to factor it? Not necessarily. Most of the time the factors are going to work out, and those are going to be nice integer numbers for a lot of these problems, not every single one. Okay, so I would say just let's go to our calculator right away. Let's take a look, let's plug this in, and let's see what we get. Here's the two places it crosses. And you don't necessarily have to draw the graph here. I'm just doing that here so you can kind of see what we're talking about. It's positive here, it's negative here, and then it's positive back over here. So it's positive to the left of negative 2. This time, though, we want a parenthesis because we're not including it. It's not equal to. This one's just greater than. And then we put the little U symbol in here. And then it goes back to positive again as this graph goes around, right? It comes here, and right here is where it crosses the x-axis, so everything to the right of 1 is where it now is positive again. So we'd say 1 to infinity. And that would be our answer. And we're still going to write it in interval notation like we've been doing throughout the semester. That would be the quickest and easiest way. And that's kind of the format that we want to write it in.
Do you have to put that U in between?
You do, because there's a break, right? And so it's not continuous forever. So just to show that it stops for a while, it drops below, and then it continues back again. If I had changed this to a less than symbol, then we would be everything between -2 and +1, right? And that would be the other scenario. If this was a parabola that opened down, then that would change things, right? Then it's going to be positive in between, and it's going to be negative on either end. So things could change depending on what the graph looks like and what type of polynomial or function that I have. Okay, questions on that one? You can always check it by plugging numbers in here, okay? But those are the places that it should be positive. Okay, if I have x squared less than or equal to 1. Like we said just a second ago, if it's not set equal to 0, or in this case less than or equal to 0, we want to get it there. We want everything on the one side together, so we're going to simply subtract 1 here. X squared is less than, x squared minus 1 is less than or equal to 0. If you wanted to factor it, you could. This is just dops, x plus 1 and x minus 1. Like I told you before, you don't necessarily have to factor it, because when I graph this one, it's going to look kind of like the other two. It's just crossing the x-axis in different places. This is at -1, this is at +1. Hey, but everything today is based on this right here, okay? So when is it equal to 0 or less than? Less than or equal to? Well, we know when it's equal to. It's equal to at 1 and -1. Where is it less than? Well, right now it's positive, right? And it's going to stay positive until I get to -1. And at -1, it's going to drop below. So it's negative right now, and it stays negative until I get over here to +1, and then it goes back above, and it's positive again. And so here it's positive, here it's negative, and here it's positive again. And based off our sign, on this one, we want to know when is it less than or equal to 0. So anytime we have an equal to right here, we know we're going to use the bracket symbols instead of the parenthesis symbols. And we're going to say everything from -1 to +1 would be a solution. Okay, and I just kind of highlighted it in red to show that's the area that we're talking about, because it's less than or equal to. Okay. So those are all quadratic equations. Not all of them are going to be quadratics. I think quadratics are probably the easiest one to understand. But, you know, it could be cubic. It could be any of the polynomials that we've talked about. I'm also going to show you one here. I'm going to give you a function. And just like we've done on the last one. So it could be any kind of polynomial. but we're going to have an inequality. So here's the function that we're given. This is a rational function that we talked about towards the end of the week last week. I want to know, when is this rational function, g of x, less than or equal to 0? We could be given any of our 4 inequalities on any of the problems today. Okay, so that's really where you're going to have to pay attention to which inequality am I given, how are we going to apply that inequality. So in this case here, x minus 2 over x plus 4, probably once again, I truly believe the easiest way to do this one is in our calculator. Okay, you can punch some numbers in, you can kind of evaluate. Solving this one's a little bit more difficult. We talked about graphing rational functions, and so we've seen these kind of graphs. But let's put this into our calculator. This one, just kind of a quick sketch. There's my vertical asymptote. There's my horizontal asymptote. And we said that it's curving like this. Now, what I should also do, and let me go back and do this again. Knowing where it crosses the x-axis is a pretty big deal. And I probably should have looked at that graph. This is where it's crossing. And then it approaches that asymptote. Okay, my inequality here is less than or equal to 0. Okay, when is this function less than or equal to 0? What is this branch of the graph right here? Positive or negative? Positive, right? Because it's all above the x-axis. Okay, over here, right next to this line right here, and that's where your asymptote's really going to come into play, is it ever going to hit -4? No, it's going to get really close to it, right? But it's never going to hit -4 because it's an asymptote, vertical asymptote. So it's going to come right up next to -4, and it's going to stay negative until it gets to 2, okay? And then it goes positive again. So what we would say here is that my solution would be -4 to 2. And we would want to bracket because 2 is where it's equal to 0, and we want to know when is it less than or equal to 0. If it was just less than, then I wouldn't have to worry about the bracket. But we also don't want to bracket here because it's never going to hit -4. It's an asymptote, and so it's going to get really close to it but never touch it. So we can't include -4 in our answer because that would give us 0 on bottom, which we can't have. Okay, so that's where that graph would be negative. Okay, the last one I'm going to talk about. Any questions on that one before we go to the last one? Okay, it's just a little bit different kind of graph. All your graphs will be a little bit different today, just like we've seen throughout the chapter. Okay, g of x equals x squared plus 4. If I said, where is g of x greater than 0? Where is g of x less than 0? So we're going to take that function that we're given. Now, if we graph this, it's another quadratic function, kind of like we've seen on the first couple of examples. If I were to graph this, and once again, you could put it into your calculator if you really want to, if you're not sure what it looks like. It's a parabola that goes up 4 and looks like this. Okay. Put it in the calculator if you're not sure about it. There's nothing wrong with that, but just to save a little bit of time here, I'm not going to pull my graph up. When is this function greater than 0? When is it positive? Always, okay? It never drops below the x-axis. So all real numbers are positive. Any number that I plug into that function will give me a positive result. When is it negative? Never, okay? So in this case, we would say no solution, okay? So in order to have both positive and negative solutions, it has to cross the x-axis at some point. If it doesn't cross the x-axis, then either they're all positive or all negative. Same thing could be true for a parabola that opens down and never comes up and crosses the x-axis the other direction. Okay, so just one of those to kind of be aware of. A little bit different kind of solutions, but should be pretty easy to identify if it never crosses the x-axis. All right, that's it for today, our lesson.